So, all right. So this is another one of our interviews that we're doing with some of our students who've been through the Math Alliance as undergraduates. And today we have Alex Barrios, who got his PhD at Purdue. So we're always very, very proud of that. And of course, Donald Cole is our interviewer again, and he's been doing a wonderful job. And we're looking forward to watching this and seeing what happens. I'm just going to let you guys have your conversation. I appreciate your time, taking the time to do this. It's really helpful.
Thank you.
All right, take care.
Yep, take care.
Thank you, David. Thanks so much for doing this. Have
Appreciate
a great day.
You too.
Oh man, so as he said, I'm Donald Cole, and we've met before, but I'm glad to see you again. And the Math Alliance is doing some of these videos in hopes that we can distribute them a lot of different places and people can see them. And we'd like to get your perspectives on some things, your experiences. And so I'll be asking a number of questions of you. Some will be open-ended, and some will be kind of closed-formed. And the whole thing should take less than an hour, but I want you to feel as if you have all the time that you need, because I'm not in any hurry, have to go anything.
Okay.
Anywhere at all. That all right?
Yep, that's perfect with me.
We'll make it happen. So let me just maybe start with the general question of having you give me a little chronological timeline of yourself to tell me where you got to where you are today. Sort of tell me where you're from originally, and then some of the schools that you went to.
Yeah. So I was born in Miami, but initially, so my parents immigrated from Colombia, and so my ancestors from Colombia. So I was born in Miami, but we actually moved around quite a bit when I was growing up. So we went to Mexico. We moved to Mexico when I was 6 months old, and then to Guatemala. And so I grew up in Guatemala for my first 6 years, and then we moved back to Miami, where I did my schooling. So specifically, I was raised in Hialeah, which is one of the suburbs outside of Miami, which is predominantly Hispanic. And so I never really grew up feeling as a minority, since actually Hialeah is the second largest, second largest city in the United States with the most Hispanic population after Laredo, Texas. And so the public library had the Cuban flag, not the US flag, but outside. And so the notion of being a minority, I did not really feel. But I was first generation. My parents, my dad never finished middle school. And so while I always liked learning, I did not have that much mentorship from my family in terms of what I can do or what was possible. And I started working at a young age. So throughout high school, I worked at the airport in Miami as moving luggage. And so when finally got to my senior year, my peers were applying to college, and I had no guidance or whatsoever in the process. So my high school was 5,000 students. We had one college guidance counselor, but for the whole school. And so I don't think I even actually ever met her while I was there. And so when I came to apply, I wanted to, my dream back then was to become a commercial airline pilot. So I only applied to one school. And so I applied to Embry-Riddle. I got accepted. And then in the financial aid package, I was only going to be receiving about $20,000, but to do the flight school, it was $55,000. And at that point, and that was per year. And so at that point, it was this is this is just not possible. We can't even afford this. And so my best friend in high school, he was applying to this honors program at our local community college. And so I applied to it, and that's where I went there after high school. So after high school, right after high school, my dad passed away. So I became the breadwinner for our family. So I started working full time, and then going to the community college there. But there is where actually I got the guidance. And so I came in high school, I've always loved mathematics. But my impression in high school of math was that it is essentially calculus is the peak of mathematical knowledge. And that's there's nothing else past calculus. And so I got to community college. I started off taking Calc 3, and the counselor, my advisor in the honors program, he took me aside at one point at the very beginning of the spring, and told me, you've been doing well. At that point I had taken Calc 3 my previous semester. I was taking differential equations in that spring, and he told me, there's this research experience for undergraduates based out of the University of Iowa. You should apply. And I was like, but I have to work. I can't really go. It's like, no, you get paid. And so I applied and I got in. And so this was actually the Alliance REU back in 2008. Yes. So that's actually my first interaction with the Alliance. It was specifically the Alliance, and it was a joint partnership with the Alliance and Bigger. I'm not sure if I'm pronouncing it right. VIGRE. Mm-hmm. And so it was essentially a consortium of specifically for the sciences, and the goal of the program was to bring underrepresented students into graduate programs in not just mathematics, but throughout the sciences. And so it's based out of the University of Iowa, Iowa State, and forgetting another one. But that was based out of the University of Iowa. But that was actually the first time I had ever left Florida when I went to that program. Oh, okay. Like I had done a study, like at least within the United States. Uh-huh. And so I got there, and at least with Hispanic culture, you're like, when you go greet people, you're like there's not this sort of separation of physical space. And I remember I went to greet someone, like they were just taking it back, like, what are you doing? And I was like, ooh, I'm no longer in Florida. And so it was the first time that I really saw how much there was out there, like that mathematics could actually be a career. Because as I mentioned earlier, like my perspective of mathematics was like, you learn it more as a tool to do something else, but not necessarily to just pursue it for its own sake. And so that summer, like we attended talks I attended talks in number theory, partial differential equations, analysis, and also on the applied side, how mathematics is used to do virtual reality. So we got the opportunity to see at Iowa State at what was at the time the largest virtual reality research center. And so I got this exposure that really galvanized me to want to pursue mathematics as a career. And also that summer was also the famed 500-year flood at Iowa. So that was a nice introduction. Very memorable.
I remember that.
Yeah, we landed in Iowa. For the first week, it was just torrential rain. And by the end of the first week of the program, they evacuated us to Ames. And then we returned back to Iowa City by the third week, I believe. And so I got back to Miami-Dade, and having had that experience, I had my eyes set on doing mathematics as getting a degree. But in college, it's quite difficult because they don't have as much course offerings. And so having already taken Calc 3 differential equations, all that they really offered was, and on top of that was a linear algebra course, and what in retrospect I would describe as a computational abstract algebra course, not proof-based. Right. And the other situation is with Miami-Dade, just to give some perspective, it's a community college, but it's not it has various campuses throughout Miami. Right. And so in order to take the classes I needed to take, and I was also pursuing physics at the time, at the last 2 terms, I was essentially driving between the 4 campuses to be able to take the classes. And so because they were just not offered on my home campus. And so I took those classes and then applied to transfer, and was fortunate to get accepted to Brown, which is where I went to continue my bachelor's. But in between those 2, transferring from Miami-Dade to Brown, I actually did another summer program at Cornell. And so this is the Summer Math Institute that Cornell ran back then. And so it's different in an RU. There is a research component, but the emphasis is that students will be taken through a graduate course through 8 weeks. And so they alternated between abstract algebra and real analysis. So the year I did it, it was abstract algebra. And I was coming in having taken a computational abstract algebra course, but this was at the graduate level. So now they're proving everything. That was completely new to me. The only proof-based course I had up to that point was a geometry course, and it was just night and day between the proofs. And it was brutal. It was in retrospect, it gave me the perseverance I would need to get through Brown and then of course graduate school. But in the time, it was quite a miserable experience as I was coming feeling like, okay, I'm good at math. And now I was surrounded by 7 other students, and some of them were actually going to grad school the following year. So I was one amongst the 2 youngest of the program. And so the other one who was also going to be a rising junior, like we bonded because we were like completely inexperienced when it came to like the math, and we were just like working together. But we did feel slow at the time because it's like everyone was like, "Oh yeah, this is fine," and I was like, "What is going on?" But at the time, it was quite miserable, just that feeling of just not knowing. But it's something that definitely did mold me in terms of becoming a mathematician, because the thing with math is it's hard, and you need to bang your head quite a bit, especially at the research stage, where it's just like, okay, that doesn't work, try again, and you just continue trying again, and just like I like to describe it nowadays to students, just like, well, you just throw darts, don't give up, just throw darts and wait until something lands.
You're going to hit something.
Yep, but just don't give up. Whatever you do, don't give up. So I did I went through Cornell, I got to Brown, and unfortunately, because I had taken a bunch of credits at Miami-Dade, Brown gave me the full 2 years of credit, and so I essentially was given an ultimatum that I had to graduate in 2 years, and as a result, I only took math, physics, and some philosophy courses on the side. But my first term there, I took linear algebra, abstract algebra, differential geometry, philosophy of math course, and consciousness course. And I was in over my head. I came in, and I was like, oh, I've taken a bunch of classes before, so this will be fine. And it was just brutal. Like the experience of taking a bunch of classes at the community college level, and then taking the same coursework at Brown, where it's like in a 12-week period, just devastated me. By the end of it, I was essentially like burnt out, but I made it through, and I just continued. I took more classes, more math courses the following spring, and I had I was very fortunate. This is a recurring theme that I want to point out. It's like throughout all of this, I had like amazing mentors and advisors that gave me good counsel. When I was at Iowa, Phil Kutzko was the leader, the RU director for the Alliance RU there. And so I got to meet him quite well. He really motivated me into like, yeah, there's so much out there for math, like analytic number theory. You start like putting in analysis and number theory, and you get like these beautiful results. And so at Cornell, Ravi Ramakrishna and Ken Brown were like pivotal in my development. When I got to Brown, Ravi Ramakrishna and Ken Brown at Cornell, they put me in contact with Johnny Guzman, who is a professor in the applied math department at Brown. And he had been one of the professors for the Cornell Summer Math Institute. And so while I never took a class from him, he took me under his wing, mentored me, and gave me advice and kept me up when like things were like not going well. Like I mentioned, the first term, my first semester was just like, it was just brutal, like just adapting to the whole transferring and taking rigorous classes. And the students that were taking the classes as well, no one had the same background in that sense from me. I was like the only person that was of color and non-Asian. And so it was a really alienating experience. And so like completely different to say growing up in Hialeah, where I never felt like a minority. Once I left, it was just like, that's just like the constant. And also you do get like these sort of experience, like the subtle vibes that we all get in this, which is like, oh, yeah, what you want to do math? Well, math is hard.
Mm.
And so you get those little snide remarks that they just sort of like bring you down at times. But I made it through. But Johnny recommended I apply for the Mathematical Sciences Research Institute undergraduate program, MSRI, for the summer going into my senior year. And so I applied and was fortunate I got in. And that's where I would really say that my interest for mathematics really was at an all-time high. Because up to that point, I would say that the experience at Cornell motivated me to do math, but for the wrong reasons. I was really doing math because I had to graduate in 2 years, and that was the subject that had the most courses. And the second point was that having felt so miserable during that summer where I was feeling like I was I felt that I was good at this and I'm no longer good. I went into it wanting to essentially prove to myself that I could do it. And in retrospect, those are not the best reasons to pursue something. But I went through the program to MSRI up, and it was in number theory research. At this point, now it's been a year from the Cornell program, but at my year at Brown, I had taken abstract algebra, differential geometry, topology, analysis, and so now I came from having almost no preparation in theoretical math to having a good amount of coursework. And it was a very good experience, and I was able to also help and mentor peers of mine who were doing the RU, and essentially I saw them as how I was the year before, where it's they're coming in, have maybe taken a linear course, and all of a sudden they're getting bombarded with all this language and terminology, and it's stressful. And it's especially for when you take students who are used to being at the top of their school, and they're in an environment where everyone is at the top of their school. It's just quite psychologically damning without any outside mentorship, where it's yeah, no, it's okay, just be aware that now you're surrounded by math majors from all these institutions who are at the top of their class, and we're all in this together. And so it was a good program. So I did number theory there, and the project that I was working on was with a question pertaining to the ABC conjecture. And so my research advisor was Edgar Goins, who will become my PhD advisor. And I remember that was one of the best experiences, in the sense that I was working on this problem, and nothing was I was just sucked into it. I was just attacking it, trying to figure out how to crack it, and things were not working. And then I just remember one night I was just working on my computer, trying to figure out something with just doing some examples, just trying to throw the kitchen sink at it. And then something worked. And then maybe I can generalize this. And I just worked through the night, and then everything just at the end, everything clicked and everything was working. And it's whoa. It's 3 weeks, and finally it's done. It's foolproof. Well, now it's to write it more precisely and rigorous, because this was just more just running through, just trying to get everything to work. But I really loved that experience. It was something that really stayed with me, that eureka sensation of having accomplished something after spending so much time and energy working at it, which is different than when you work on a homework exercise. Because with a homework exercise, you have the time limit. Okay, you're going to be turning it in at the end of the week, but that's always everyone else working on it. Whereas here, it's oh, this is a problem which no one has really considered before. So there's still that question, will it even work? And so one of the things that was difficult for the project that I was working on is that they were broken into 4 cases, and 2 of the cases were not like the other 2. And so they required very special conditions in order for them to work. And that was the subtlety that was causing them, every attack that I had been working on up to that point was failing it, because that aspect where it really boiled down to a divisibility by 3. And once those examples were there, it was oh, this is not working. So what if I eliminate this from consideration? And then there were some inequalities to consider, and all of a sudden, everything just fell in place. And so the research was with number theory, ABC conjectures, was very similar. It was very related to Fermat's last theorem. And that was a statement that really motivated me. I had not heard, the first time I heard about Fermat's theorem was actually at the Cornell program. And it was just baffling how this question that's so easy to understand, there's no natural number solutions to x to the n plus y to the n equals z to the n for n at least 3, is just like, for 357 years, mathematicians worked at it, and it's so simple to state, like,
That's right.
what's happening. And so that summer, like, it was my first exposure to number theory and elliptic curves, and that's essentially the pathway to Fermat's theorem. And so when I got to my senior year at Brown, I was approaching it, I was like with a different mentality. It's like, I want to go to graduate school. But again, maybe not for the best of reasons. I wanted to go to graduate school so I can understand the proof of Fermat's theorem. Like, the research was like, okay, that's like my side project, but I really want to understand that proof.
Okay.
And so I applied to graduate school, but my goal was to work with the research advisor from the MSRIA program. And so I applied to Purdue and got in. And so I went to Purdue and worked under Edric Owens. And while my research initially was on class field theory and topological homology, towards the very end of my thesis, so I started working on something else that's sort of like a side project. And that side project ended up generalizing the results from the summer program at Berkeley at MSRI. And in the end, I was able to I was able to provide a constructive proof for a result that was done in arithmetic geometry in the 80s due to Flexner, Osterley, and Fry. And by having this constructive method, I was able to not just generalize the result from the summer at Berkeley, but be able to produce a bunch of examples that were not known beforehand about what are known as good elliptic curves. And so essentially what happens is you have the ABC conjecture. And what the ABC conjecture says at its core is that it's very rare to have natural numbers A, B, and C that are relatively prime, such that if you have A plus B equals C, that you'll have that then C. So they're natural numbers, so they're all positive. So then the C, which will be the greatest of the two, A and B, since you're adding the two positive numbers. And so roughly speaking, what ABC conjecture says is that it's very rare to have C is less than the product of the distinct products, the distinct primes of A times B times C. So for example, we take 1 plus 8 equals 9. If we take the product of the distinct prime factors of 1 times 8 and 9, you'll have 6. Right? And so in this case, you'll have that 6 is less than 9. And so what the ABC conjecture says is that this is a rare instance, like this should rarely happen. And so the more precise statement will have that there's an epsilon greater than 0, and there will be finally many of these like possibilities to happen for any such given epsilon. But the thing with ABC is that there is an equivalent statement in the realm of elliptic curves known as the modified Shapiro conjecture. And in this realm, now you have this equivalence. So you prove modified Shapiro, you get ABC, and vice versa. But you can translate all the language from the ABC conjecture, and like there's this notion of good ABC triples. So the 1 plus 8 equals 9 is an example. So you can translate it into the realm of elliptic curves, and there's now a notion of a good elliptic curve. So Master in 1990 had proven that there's infinitely many of these good elliptic curves, and there's infinitely many good ABC triples. But there's a lot of the literature on ABC triples, since now you're talking about things just pertaining to the integers. It's much easier to work with. Whereas over elliptic curves, the proofs were non-constructive. They were more of like, there exists, but okay, well, find them. And so my thesis sort of took a U-turn in that by proving this result constructively of Flexner, Fry, and Osterley, I was then able to use that to prove Master's result and find a constructive way of finding these good elliptic curves, but also completely generalizing the results to just what are known as like different torsion subgroups of elliptic curves, and having them that there's infinitely many that are good. And so it was a nice sort of like full circle where it's this like project that I started off working in 2010 during MSRI Up. And then in my actual research, I inadvertently stumbled upon it without even planning to do that.
It's very neat, and very rare that
Yeah.
yeah, that would
But
happen.
yeah, so it's been a fun journey going through this and so now I'm a visiting assistant professor at Carleton College outside of Minneapolis in Northfield, Minnesota.
Okay.
And so that's been also very fun since I really enjoy, one of the things that has really motivated me as when it comes to learning is to understand the history and what were the motivating questions that led mathematicians to even consider these questions. Because oftentimes when we read a book, it's theorem, proof, which
Yeah.
is easy to push symbols and go through the proof and be like, yeah, I buy that. But the intuition of how someone even came up with that proof, that's a whole different story.
That's right.
And for every theorem, there's humans that were behind it, that worked for years. And our profession is one that does not like to show its weaknesses and mistakes. And so you only see the final proof, like the shortest path from A to B, but you don't see all the failures that happen in between. But by learning the history, you get to see those failures. You get to see how someone like Euler would take 50 years of his life just to go from the n equals 4 case of Fermat's theorem to the n equals 3 case. And even then, he made an error in that proof.
That's right. That is so true, Alex. So true. You said something that caught my interest a little bit. I want to back up a little bit. And since the Alliance is sponsoring many of these interviews, I want you to go back and tell me clarify a little bit about how you first heard about the Alliance and your experience with the Alliance, and when you think back and close your eyes and reflect upon the Alliance, what a couple of things that come into mind.
Yeah, so as I mentioned, when my first interaction with the Alliance was through the 2008 Alliance Bigger RU that was out at the University of Iowa. And so this was a 8-week program. And during that program, aside from the flood that I mentioned earlier, the intent was to get undergraduates to get experience doing research. So I worked under Augusto Rumerick at Iowa in a project on minimizing energy graphs on the plane. And so this was his research areas in differential geometry. And so at that point, I had some differential geometry, not differential geometry, differential equations, Calc 3. And so the project was based on just knowledge of Calc 3 and multivariable calculus. But it was essentially looking at these sort of questions that can be applied to chemistry. So when you have, say, like a water molecule, you have H2O, we know that the angles between the atoms are 120 degrees. But you can generalize the sort of like the actual bonds between the atoms in terms of like essentially springs. And so you can think about the actual bonds as springs, and now you can look at this from a research perspective. And so these sort of like applications from mathematics were like one of the first things that got me interested in like pursuing math as a actual career. And so for that, I'm indebted to the Alliance. So like that was like my first instance. Had I not had that experience, I am pretty sure I would not be here. Since I would not have had that notion of like, yeah, you can actually get a career just doing mathematics.
Yeah, okay.
But afterwards, so also the opportunity to go speak at conferences. So we had a research symposium at Iowa where we were able to present our research for the summer. And so getting that experience of giving a talk and then having other mathematicians also like not just pay attention, but value what you have done and congratulate you. And so that was really, it was an experience I had never had before. And so that was my first experience with the Alliance. And of course, as I went to graduate school, then you have the Field of Dreams conference.
Right.
But when I went to the Field of Dreams conference, I went at it now as for my graduate students. And so it was, even though I had already participated through the RU, going back as a graduate student allowed me to also interact with students that were undergrads and motivate them and captivate them that there's much more to mathematics than just what we see in the undergraduate curriculum.
Yes.
And also represent, because one of the aspects of math is that there's very few that look like us. And so it's nice, you know, to when you go somewhere and it's like, oh, you're not alone.
Yes, for sure. Alex, you have a PhD in mathematics. You must be a genius. What do you say to when people say that? How do you react when people say something like that?
My wife would disagree. Yes, but it's one of these aspects where we put these sort of degrees on a pedestal, and at the end of the day, yes, we are knowledgeable in the area of the research that we got, but we have like a very fine, like we're just narrow-minded in that area, and so like I'm perfectly fine just being like I'm completely ignorant to a lot of other things that I would like to learn, but I'm open to learning about them. Just be aware that yes, I have a PhD now, but I did not always have a PhD, and it takes years of work, and that's one of the aspects with academics. I like to use the metaphor for students with sports, because when no one bats an eye when you talk about, say, someone like a football player or a baseball player, and yeah, they train after school, and then if they go into like the major sports, they're also training every day. And you know that they have to train if they want to maintain that level of activity and performance. And so no one questions them about that. But when it comes to academics, you don't see the training because it oftentimes happens in isolation. Like you read a book, you're studying, you're doing this work, but on the outside, no one really sees this. And so this is one thing coming from being first generation that was very difficult, at least to convey to my family, in that them having not had a formal education, like I will be spending all this time reading, and then the Hispanic culture is very social, and they were very social, and I would prefer like to read over like going to like social activities, and that was something that I had to struggle with, like the distractions. But or it's like, oh, you're already doing well, you got a good grade, like why do you have to do even more? But the thing with all of this is you have to continue like working, and there's always more to learn. And like I would say that when I was younger, I was very interested in trying to learn as much as possible. And then as you go into a PhD program in mathematics, then you go from wanting to learn about all the various things to, well, I need to learn this one thing very well. And so it means that I can no longer keep track of what's happening in physics, which I really loved. And then we're like reading books about string theory. And like nowadays it's just like, I just know like layman's terms of physics, even though I took all these courses. It's like, but that's like the aspect of like doing, like, I would not say that we are geniuses, but more that we are very specialized professionals that for us in academia, we devote our careers to just going through this very like tiny like aspect of humanity.
Oh, I like that. I like the responses. But I like your analogy with the with sports and how they have to train.
Yes.
They train just in that one sport.
Yep.
As well.
And I taught high school students for 5 years as a graduate student at Purdue. And so one of the things about it was really a very good experience teaching them, because it really got me to, how do you motivate them to get interested in mathematics? Like you have to come up with a clever analogies, keep them interested. And so this was it was called the Minority Engineering Program that Purdue University holds. And it's 6th through 12th grade summer camps. And so the 6th through 10th grade camps are just 1 week long, but the 11th and 12th grade camps, those are 5 week long. So I was the lead instructor for them for 5 years. And so I taught SAT mathematics to the 11th graders. And then I taught calculus for the seniors that were actually coming into Purdue in the fall. And so my goal was always, I'm gonna use these 5 weeks to motivate you and like see the beauties of mathematics and give you questions that really make you question, why are the statements the way that they are? but more in particular, like you have like it got me to like make these analogies and try to find ways of connecting with students that may have had bad experiences with math. Because that's one of the things I have found is that most people, you know, we tell them, oh, I'm a mathematician. Oh, I hate math. Flying on planes. It's like that's like the one thing I dread. I get in the plane. It's like, what do you do? Math. Oh, I hate math. It's like no one ever says like, oh, what do you do? Oh, I'm a reporter. Oh, I hate journalism, or I hate art. Like no one ever says. But with math, it's like everyone is just prideful of just like telling you. But I don't blame it. But it's in part also from all it takes is just one bad experience with one teacher, and that's all that it takes. And from that point on, there is an aversion to mathematics.
Yeah.
And one of the things as an educator that you have to be aware of is how do you come across as someone who has had a aversion to mathematics because of one or multiple people. And maybe they have trauma from going to the board and maybe made to feel dumb. And how do you reach to them and get them interested in mathematics and to see it from a different perspective and to see past their trauma, because it really is PTSD for some folks who have had these bad experiences.
Alex, give me an instance for which in your career you almost felt devastated and almost ready to give up mathematics, and then go to the other extreme and give me an instance for which you were very proud mathematically of some things that you've done.
Ooh, there's been many of those moments.
both.
Yeah.
Just pull out one.
Yeah, I would say I remember when I was at Cornell, by the second week, so we were doing abstract algebra as a graduate, like essentially we're going through Dominant Foot, the graduate level textbook, and we're just flying through the book, and I'm here struggling with the definition of like what it means to be a group, and we already like are reaching Zeto's theorems, and I cannot even get through like the basic definitions, and I just felt like giving up. It was just so painful because everyone around me was like getting it, and I'm here like, why am I so slow at this? I'm like, I've been working, I'm writing notes, and I just want to go home. Like I just want to be done with this. I made a wrong decision, and I was also going into Brown that coming fall, and so all of a sudden I'm like, is this what I'm supposed to expect? And apparently my depression came up, like was noticeable because the director, Ken Brown, took me aside. He took me out to lunch, and you know, he chatted with me, and he was like, you know, math is hard. Like it's hard. It's you, when you all see us, you just see the final product. Like when he told me his story that he didn't want to necessarily do math initially because he was his older brother was also was a mathematician, and so he was always the one that everyone always talked about growing up, and so he had an aversion towards math in that sense, and so he went like he grew up in the Northeast, and so when he went to college, he wanted to go as far away from his brother, so he went to Stanford. I forget where. I think he went to Stanford, somewhere in the West Coast for sure, and he was doing a psychology major. And it was not until his like junior year that he started looking at some math like question. He got really interested in it, and he was like, "Oh, I want to do math." And he worked on it, struggled, and things were just not going well. But he just kept at it, and that was really just motivating. Like the fact that like you know you go from something you've been working on and just like do a complete 180, knowing that you don't have that advantage that everyone else who has been working on it has had over the years of taking classes. And then if you say in his mind, he was like, oh, I need to go to graduate school, so I need to take all these math classes. And that it was not easy. He struggled, and he told me like the way you want to approach problems is as a puzzle. You want to approach it as you have this theorem you want to prove. Well, ask what are all the results that you have leading up to it, and so put them down. Think about it as a flow chart, and then just like move things around until you finally get it to click. But he was very motivational, and at that point, I was just really feeling down that I just wanted to call it quits. And like it was definitely one of those like life-turning moments where Had that conversation not happened, I would have probably just like left the
Mm,
program.
interesting. Interesting. Okay. Okay. And give me the other extreme example of a.
So last summer, I co-directed the Pomona Research in Mathematics Experience Prime with my former advisor, Edgar Goins. And so we both had our two research groups. And so the first 2 weeks, we gave lectures on like the material that was like at the intersection of both of those the topics that both research groups would need. But then for the next 6 weeks, I was working with my group exclusively. And it was definitely a joy being on the other side, like having gone through our reviews and now being like the one in charge of an actual research project that was actually based on like an extension of what I had done in my thesis and directing it. And then seeing them go through this phase of like, oh, what is going on? What's happening, to understanding. And by the end, like being knowledgeable and having their own proofs that they themselves had made, like devised. And watching them present was definitely a very emotional moment for me. And so they presented at the MA Math Fest this last summer, and they won the number theory prize for best presentation. And so that was definitely like it was definitely an amazing experience, like going from being the student to now being the research leader.
Yes.
And just you see them, you interact with them the whole time. You see them like learning it for the first time, assimilating knowledge, making those mistakes. But you also have to know that you were supposed to give them the space to make their mistakes, to get that experience, that ownership, that is their research, and that they are the ones making the contributions. And so just trying to make that fine line of giving encouragement while also giving them the space to work, but then seeing them, once they get that confidence, take ownership of that work. And not only like they surpassed my expectations. And then when they went to give their presentation at Math Fest, it was just phenomenal, just like being in the audience and seeing like the execution. And it was pleasing just to see them like earn the prize that was well deserved.
Okay, you felt like a father who's birthed all of these great children. I can understand that. If you had to do everything all over again, what would you do differently?
That's a hard question to answer, because at the end of the day, we are like essentially the products of our experiences. Even like the bad and good experiences, they molded us to be the person we are. Yeah, that's there's some aspects where I do regret not having had the opportunity to have taken like certain courses early on that would have maybe made a difference in terms of like maybe more career opportunities. Because while I do love mathematics, I got lucky. And it's one of these things, like our experiences are unique to us. Like they don't necessarily apply to everyone else. But one of the things I do wish I had like early on was like more like programming experience, the opportunity to like take actual like classes in programming, because that also opens a lot more doors. Because I definitely did feel at one point that I was pursuing math because I was getting a degree in pure math, but also did not really know of the career options that were available. And so it worked out for me, but it definitely, there's that what if like situation that I do tell students, like, you want to take as much advantage and you want to have as much knowledge as possible of the different opportunities to best give yourself that experience. Yeah, it's a difficult. Yeah.
Okay, that I understand. But let me follow that with another question, because we're going to be showing this interview to lots of people. I suspect that there'll be some little girl who's 12 years old who's watching this. There'll be some boy who's 18-year-old who's watching this, a college student. There might be a non-traditional student that's watching this as well. and they have an interest in mathematics. And I'd just like you to pick a group, a category, or age, and speak to them. And what would you tell them in terms of advice, in terms of a mathematical career from where they are now? What advice would you give?
Okay. Yes, I can speak to two categories, but I'll have different responses to those. So if for someone who is either high school or like early college, and they're looking at mathematics, one of the things I would say is that mathematics is not what you see in your in the schooling that you had up to that point. Oftentimes we go through these courses, algebra, trigonometry, and we are really just going through identities and equations, but we don't see that beauty and art necessarily in those courses. Whereas modern mathematics is, in my opinion, more like art. You can use your creativity, and yes, you do have the option. You do have the ability to give an answer in two different ways in some of these courses, but you don't really get that experience until much later, where you get to not just say that square root of 2 is irrational, but you get to give a proof definitively that it is irrational. And that's one of the things about mathematics is that you don't see early on, is that every definition that we are given throughout our schooling has a motivation and can be proved, and it's not just a definition. And so this aspect of looking at mathematics, not for what they have experienced, but for what it could be.
Okay. Thank you. And I think that's going to be very, very well received. Matter of fact, I know it will because I'm receiving that.
The other one, especially for those of us on like that are definitely not on the representative amongst mathematics. Mathematics has had a history of exclusion that has been through its inception. And you can look at through its history and see many figures who were also oppressed and made contributions. And while we may still not have the representation that is proportional to the population of this country, we, with each generation has essentially moved the needle closer and closer to equity. And we can see this throughout not just the 20th century, but even going, say, to the 1800s, you have people like Sophie Germain who had to work under a pseudonym just to get recognition for her work. And it was not until she won the Paris Academy of Science Prize that she was actually publishing under her own name. And in many ways, like this woman who went against social norms to do what she loved, and in some ways got penalized for it in her own personal life. She made one of the biggest contributions in modern mathematics in the sense that she was the first to see that Fermat's last theorem, which could be approached from a very general perspective. And she essentially paved the road to what would become abstract algebra indirectly. And so these are the stories that I sort of like I find amazing, is that we tend not to see this representation. But if we look beneath the surface of what we tend to see in the books, we actually do see that these stories are like, where will we be if everyone actually had equal access to education? Like how many more discoveries would we have?
Yes. Very good point. Very good point. Yeah. You maybe already did this, but I'd just like to explore it a little bit more. If you would describe again the community that you grew up in, and now you're a professional mathematician and college professor, if you will. And these are probably different communities. And how do you sort of relate these two communities somehow mathematically? You sort of talk about them and describe them. Describe them somehow through the lens of mathematics kind of help define these two communities or say something about them or something of that nature. Just kind of talk about those and use the mathematics in there somewhere.
Yeah, no, it's difficult. The community in which I grew up in was low income. So our school was overpopulated. So we have, at that time, almost 5,000 students for the high school. So we did not have as much resources. It was understaffed. So like at the end, there was no calculus BC class. It was essentially like, if you want to take BC, you study it on your own. It's very different than like the communities where I interact with now, where it's professionals and at least but that's sort of more from like the perspective I see it now, but my experience is being lived by millions right now, where they have essentially, they're going to schools like mine. And the key thing is getting that encouragement and having someone to be in your corner to motivate you to push through not just mathematics but STEM. It's like when I reflect back, like while the community that I grew up in, it had its faults, but it did the best that it could with the resources they had. But it definitely is one of these things where I look back and it's like, how can we make more change? How can we bring in more representation, and also like these ideas and the opportunities that are available? Because oftentimes when I reflect back on like when I was growing up, I did not have this notion that there was all these careers that one could do other than the traditional, like, oh, you become a lawyer, or you become a doctor, a police officer, firefighter. These very naive notions. And so from a mathematician's perspective, the key is doing more outreach, bringing in more students from underrepresented neighborhoods, and as well as like low-income neighborhoods, to be able to experience not just mathematics, but STEM and all the opportunities that it provides, whether one goes through academia or industry. It just opens the doors to so many possibilities. And so in sum, I would say it will be more of making outreach programs to bridge the communities together.
Yes, and you're a benefactor of some of those programs, and we'd like to think that the Alliance was once such a program.
Yep.
But let me shift and maybe ask another question and feel comfortable to answer. If you don't want to answer, that's okay as well. But we probably would be amiss if we didn't have you comment a little bit on the today's social climate that America kind of finds itself in, as it debates police brutality as it goes, and talks about and looks at the social unrest that we're having, and the death of George Floyd, etc. And so, and now you are a professional, mathematician, and so somehow we'd like to maybe think that some of these things are not totally removed from you, but you have a perspective on some of not only mathematics, but some of our social issues and ills as well. And so let me just hear you reflect upon that for a moment, if you feel comfortable in doing so.
Of course. It's unfortunate, beyond unfortunate with George Floyd, but it's not I feel that now we're reaching sort of a reckoning, because it's just hitting a perfect storm with the unemployment crisis and COVID-19. But like speaking to the choir, these things have been happening since the inception of this country and before. And it's miserable in that we in 2020 have not made that progress that Dr. Martin Luther King envisioned. We had the death of Eric Garner, and same situation, I can't breathe. And it galvanized people to protest following it, and then it subsided. And now we are here, the same situation, I can't breathe. And it's painful, because for those of us, like, it's like, I would say, like, especially for the African American community, that these could be your family members, it could be you. And like, I was reading an article this morning of a 20-year-old Mexican American who lives in San Francisco, was arriving to his home, and a white couple stopped him from entering his home because he did not live there and that he was tailgating to rob the place. And these are the only reason we hear about this is because they had a phone and they recorded the incident. But how many of these incidents have happened decade after decade after decade, and there was no camera to record it? And what I wish people were more aware of is that this is not unique to the times. We only see it now because we have more access to technology that can record things on the spot. But it is a disservice to say that this is something that is about now. It has never been about now. It has been happening and continues to happen. We can look at the civil rights movement and the atrocities committed towards the Black Panthers and the many who were protesting in favor of equity. And if we go even further, like, well, it just becomes more atrocious. But nothing, like, what I do wish is that moving forward, that once we make it to the other side of this, that actual change is implemented.
Yes. Okay. Okay. Thank you. Thank you so much, Alex. We've had opportunity to look at Alex 10 years ago, and we've had the opportunity to look at Alex today and where he is. So let's take one quick look at Alex in the future. What do you see when you look 10 years down the road, 20 years down the road, etc.? What will Alex be doing?
I find myself fortunate to be in a profession where I could do research in the things I love and get paid for it. That's something I really enjoy, but I also value being able to give back. As I mentioned earlier, like, throughout Purdue, I was part of the minority engineering program, trying to motivate students from underrepresented backgrounds to go into engineering. And now as a professional, that's something that I've been continuing further. Last summer, we ran a RU out of Pomona, where the majority of the students were underrepresented. MSRI up this summer, and that's something that I do envision myself continuing, bringing in more students and showing them the potential that one can do mathematics. And the mathematics opens the doors to so many opportunities. But portraying that while being also honest with them, because it's not, as much as we want to bring in more students into mathematics, we also need them throughout our society as well. We need professionals versed in mathematics. And so in many ways, one of the things I do envision is continue working with outreach programs that are centered in bringing more underrepresented students and showing them that they could also be like us. And yes, math is hard, but they have the mentors there to look out after them, give them advice, and that they too can make it.
Okay. During this interview, Alex, we wanted individuals to be able to see Alex, what motivated him and what some of the things that got him to where he is today. And so we asked several questions toward that end, but I'm wondering if we didn't ask any questions. Was there a question that we did ask that'll help us to understand and see Alex in some other light that we hadn't covered? So this is maybe an opportunity for you to give some closing remarks to motivate some individuals who might be watching this, or tell them a little bit more about your story that we didn't hear, didn't ask about. So just have at it any way that you want to respond.
What I would say is, we have our time here on this planet, and the way I see it is we could all push forward to make it better for the future generations and make incremental change and progress. So I know that I've benefited so much from mentors and advisors who have adhered to that model of like making change and pushing forward the boundaries. And while we look at the circumstances around us that we can nitpick and be like, yeah, things are not the way that we wish it be, but we can be the change that can help be to get to where we would like it to be. And it's and and this is sort of like repeating some of the aspects we've chatted on, but definitely for those who find themselves struggling and that things may not be going the way that they would like it to be, whether it be grades or financially, it's if it's possible, education is an investment and it pays off in the long run, even though it is a sacrifice. I know, speaking as someone that was first generation, one of the hardest parts about it is that when you're coming from, especially from low income families, where it is a sacrifice you have to make, where you could, by going to grad school, you're not making that much income, and the income that you're making is specifically to pay off your bills in graduate school. But in terms of your family, you can't really provide much. And so it's definitely not an easy decision. But it is just even getting a master's degree, PhD in these fields, it opens the doors to so many different career opportunities that while a bachelor's does unlock doors, a master's does so much. And so if you find yourself in a position where you are debating the question of whether to go and pursue a higher degree, and looking at it from an immediate moment that you need the money now, and taking that extra time to get that master's degree or a PhD, that it may not be worth it if it's, while tempting at the moment, it is something to keep in mind, that what is best in terms of the long term. And of course, it's a matter of being sensitive to the situation. So I know friends who've had to leave school, not because they wanted to, but also they had to take care of their parents. And that's a hard thing. It's a hard question to consider and ask, like, how does one proceed if something does go wrong? and it reminds me of this article where if you're coming from like low income, you essentially need like 20 years of everything going just right. And that's one thing that I do find myself oftentimes like sort of struggling with, which is like, how do you give advice to someone, and especially like someone who was in my situation growing up, and be cognizant that there is just not the, like, just to say like, yeah, you should go and pursue higher education and higher degree can be very insensitive to the reality surrounding them and what they need. But I would say that definitely to be mindful, if you can, that the opportunities it will provide you are worth the worth the 2 years of, or even, well, in the case of the master's, the 2 years of not having that steady paycheck that you'll have right out of a bachelor's.
Mm-hmm.
And that there's a lot of funding towards getting these degrees as well. And so be mindful of that and apply to as many things as you can, from scholarships to fellowships, because the worst they can ever say is no. And if you don't apply, then you're definitely getting a no. But don't sell yourself short.
Mm-hmm. Mm-hmm. I appreciate a sentence or two that you said there. I always use the word delayed gratification.
Mm-hmm.
In terms of taking the sacrifice to get that extra degree, because it not only boosts you, it puts you in position that you can help so many others along the way. So I certainly appreciate you saying that to the audience. Well, Alex, you are a remarkable person. You're very articulate, and you've done great things in life. You're already been a good mentor to a lot of people, and you're going to continue to be a good mentor. And I really look forward to following your career, seeing where you are 10, 20 years from now. And so I want to thank you for taking the time off to do this interview. I said it'll be a little less than an hour, but we've been a little more than an hour, but then I appreciate your patience sticking in here and giving your heart out as you answered these various questions. And some of them I know were very personal in nature as well. So we certainly appreciate that. And we'll get a chance for you to see this interview and edit it and take anything out that you don't want in there, etc. And so otherwise, I just want to go and have you bid you a good day, and to thank you again for helping out the Alliance. You are the superb type of student that the Alliance wanted to be associated with, and that's why we chose you for this interview.
Thank you. I really appreciate the opportunity.
Okay. All right. Well, good luck with everything, and you go have a great day.
You too. Yeah, thank you so much for your time.
All right. Talk to you later.
All right.
All right.
Take care. Bye-bye.